Hello students, how are you all? Today we are going to discuss chapter 5 acids, bases and salts. Let's warm up. Collect the edible things given below which are easily available at home. Blindfold your friend and ask him or her to identify different substances one by one just by testing them. Record the observation in the table given below. So student, you can do this with your friends and it's very easy. Now come to the points we have. Let's know about acids and bases, classification of bases, neutralization in everyday life, salts. So student, these are the topics we are going to discuss in this chapter. We all are familiar with the sour, bitter and salty tastes of different edible substances. Let us list some of these common substances and their tastes in the table given below. So student, आप सबको पता है sour taste कैसा होता है, salty कैसा होता है, because ये हमारी अपने daily life के चीजें हैं जो हमें feel होती है. Now look at this table. We have substances, tastes. Lemon juice sour, orange juice sour, vinegar sour, curd sour, tamarind sour, common salt salty, amla sour, baking soda bitter, unripe mango sour. So student, I think you all know about these substances. The sour, bitter and salty tastes of these substances are due to the acidic, basic and salty natures of these substances. So student, उनके taste किस पे depend करते हैं? उनकी nature पे. Now we have acids and bases. All sour testing materials contain acids. The chemical nature of these substances is acid. Thus, acids are the substances having sour tastes. Examples are curd, lemon juice, orange juice, vinegar, etc. The acids in these substances are natural acids. Some of the common natural acids and the substances which contain these acids are given in the following table. So students, जो खाने की चीजें खट्टी होती है उनमें क्या present होता है? आपका acid present होता है. Here we have name of acids found in substances: formic acid and cystine, acetic acid, vinegar, citric acid, citrus fruits, lemons, oranges, etc. Lactic acid, milk, curd, ascorbic acid, amla, tartaric acid, unripe mango, turmeric, etc. and oxalic acid, spinach. So student, these are the different type of natural acid. They are present in our food materials. Here we have, apart from the acidic taste, some substances taste bitter. For example, the taste of baking soda is bitter. On rubbing the aqueous solution of baking soda between fingers, we feel soapy. This type of substances which are bitter in taste and feel soapy on touching are called bases. Thus, bases are the substance which taste bitter and feel soapy on touching. Examples are soap, baking soda, etc. The chemical nature of these substances is basic. Some of the common bases are the substances which contain these are listed in the following table. So students, जो substance क्या होता है? bitter होते हैं taste में और touch करने पे soapy feel होता है. So they are basics. Now we have name of the bases found in substances: sodium hydroxide and potassium hydroxide soap, calcium hydroxide lime water, magnesium hydroxide milk of magnesia, ammonium hydroxide window cleaner. Now students, we are going to read about the indicator. So student, what is indicator? Which indicates you that is acid, that is base. Okay. Now learn something from here. We cannot taste every substance as every substance is not edible. In such cases, like the nature of substances can be determined by the use of a special type of substances called indicators. Indicators are the substances which change the color of the solution of acidic or basic substances when added in these solutions. Turmeric, litmus, China rose petals, Goodhull, etc. are some of the naturally occurring indicators. So students, आपको ये पता करने के लिए कि क्या आपका एसिड है क्या बेस है, कुछ इंडिकेटर्स होते हैं, ठीक है, और कुछ हमारे पास नेचुरल इंडिकेटर्स भी होते हैं. नाउ लुक हियर, नेचुरल इंडिकेटर्स अराउंड अस. लिटमस, अ नेचुरल डाई. Litmus is the most commonly used natural indicator. It is extracted from lichens. It has purple color in distilled water, neutral water. It turns red when added to an acidic solution and blue when added to a basic solution. It is available in the form of solution or in the form of strips of paper, known as litmus paper. Generally, it is available in two colors, blue litmus paper and red litmus paper. Blue litmus paper turns red when dipped in acidic solution and red litmus paper turns blue when dipped in basic solution. So student, first हमारे पास था litmus. अगर हम बात करें, litmus एक नेचुरल इंडिकेटर है जो मोस्ट कॉमनली यूज किया जाता है. लिटमस दो टाइप का होता है, एक आपके पास पेपर फॉर्म में होता है, एक आपके पास लिक्विड फॉर्म में होता है. अगर हम लिक्विड की बात करें तो पर्पल कलर का होता है. अगर आप उससे एसिड में ड्रॉप करेंगे तो वो रेड कलर शो करेगा, तो दैट मीन्स दैट इज एसिड. और अगर आप बात करते हैं बेस की, तो वो बेस में ब्लू कलर शो करता है. गेट इट स्टूडेंट? लुक हियर, रेड लिटमस पेपर, रेड एंड ब्लू लिटमस पेपर. नाउ वी हैव टर्मरिक, अनदर नेचुरल इंडिकेटर. टर्मरिक, हल्दी, can also be used as an indicator. It is the most commonly used spice in our kitchen. Turmeric, the root of turmeric plant, is a yellow colored substance. Its color is pink in acidic solution and brick red in basic solution. So student, अगर हम turmeric की बात करें तो pink होता है acid में और brick red होता है basic solutions में. Let us prepare the turmeric paper from turmeric powder in the following activity. Here we have activity. Activity 1. Aim to demonstrate turmeric as an indicator. Things required: turmeric powder, dishwashing powder, vinegar, water, 3 small bowls, 2 pieces of tissue paper and a cotton earbud. Method: put some turmeric powder in a bowl, add a little water to make a smooth paste. Smear the paste evenly over both the tissue papers and let them dry completely. Take small amounts of dishwashing solution and vinegar in separate bowls. Use a cotton earbud to draw a flower on one dried yellow tissue paper with vinegar and the other with the shop solution. What do you see? So student, what you have to do, that's how you have to prepare turmeric paper. Then you have to draw the flowers of vinegar on one paper, and on another paper you have to draw a flower with the help of earbud of soap solution. Now we have observation. The flower drawn with vinegar is not visible, whereas the one drawn with shop solution turns red. How does this occur? Explanation: curcumin, an active ingredient of turmeric, acts as an indicator. It remains yellow in acidic vinegar or neutral solutions and turns red in basic solution, soap solution. So students, that's why विनेगर में वो क्या रहा आपको दिखाई नहीं दिया और रेड हो गया, बिकॉज उसमें बेसिक सॉल्यूशन था, सोप सॉल्यूशन. लुक एट दीज पिक्चर्स, वी हैव विनेगर, सोप. नाउ विनेगर, सोप सॉल्यूशन. नाउ स्टूडेंट्स, वी हैव China rose, yet another indicator. China rose Goodhull is also a natural indicator. It is extracted from the red flowers of China rose plant with warm water. Its color is light pink in neutral solution, which changes to green in basic solution and deep pink magenta in acidic solution. Get it students? So that's how जो China red rose है वो अपने color change करता है. Now we have a table, indicators, color of solution, basic, neutral, acidic. So students, ये different जो आपके indicators हैं ये इस type का color show करते हैं in different type के solutions में. First we have litmus. In basic, blue. In neutral, violet. In acidic, it's red. Then we have turmeric. In basic, red. Neutral, yellow. Is acidic, pink. Then we have China rose. In basic, green. In neutral, light pink. In acidic, dark pink. Then we have methyl orange. It is in base yellow in basic, orange in neutral, and pink in acidic. Then we have phenolphthalein. It is pink in basic, colorless in neutral, and colorless in acid. Now students, we have activity 3. Aim to demonstrate whether the substance is acidic, basic, or neutral using red cabbage juice as an indicator. Things required: red cabbage juice, vinegar, ammonia, distilled water, and 3 test tubes. Method: take vinegar, ammonia and distilled water in the test tubes. Put a few drops of red cabbage juice in each test tube. Note the color change. Observation: you will see that vinegar turns red, ammonia turns greenish yellow and the distilled water turns purple. Get it, students? Now we have methyl orange and phenolphthalein. Methyl orange and phenolphthalein are the two most commonly used synthetic indicators. Given below table shows the colors of these indicators in basic, neutral and acidic medium. Now we have students' classification of acids. Acids can be classified as mineral acids and organic acids. Here, hydrochloric acid HCl, sulfuric acid H2SO4 and nitric acid HNO3 are the mineral acids. These are the strong acids. So students, mineral acid क्या होते हैं? Strong acid होते हैं. Then we have naturally occurring acids like formic acid, acetic acid, lactic acid, etc. are the organic acids. These are the weak acids. Acids can be classified as concentrated and dilute acid. If maximum amount of acidic gas is dissolved in minimum amount of water, then the concentration of resulting solution is maximum and the solution is concentrated solution. Get it, students? Now, one can prepare the dilute solution of different esters by slowly adding the requisite amount of concentrated acid in the fixed amount of water. So student, आपको पता है कि जैसे हमने पढ़ा मिनरल एसिड होते हैं, नेचुरल एसिड होते हैं, वैसे डाइल्यूट और कंसंट्रेटेड एसिड होते हैं. कंसंट्रेटेड की बात करें तो कंसंट्रेटेड में आपके एसिड में वाटर की मिक्सिंग बहुत कम होती है और डाइल्यूट में हम वाटर की प्रेजेंस ज्यादा होती है इन कंपैरिजन ऑफ एसिड. Here we have physical properties of acid. Following are some of the physical properties of acids. Acid taste sour. Acid turns blue litmus paper red. Acid solutions conduct electricity. Acids are corrosive in nature. Acids are readily soluble in water and produces a lot of heat. So student, I think you know all about these things. So these are the properties of acids. Now we have uses of acid. Concentrated hydrochloric acid HCl, sulfuric acid H2SO4 and nitric acid HNO3 are used in large number of metallurgical operations, manufacture of fertilizers and preparation of a large number of industrial chemicals. These acids are also used in laboratories. So these are the use of acids. Following are some of important uses of these acids. Here we have hydrochloric acid HCl. It is used as an important laboratory reagent. It is used to prepare aquaresia, 3 parts HCl and 1 part HNO3 to dissolve metals like gold and platinum. It is used in the textile and dyeing industries. So student, ये आपके hydrochloric acid के use है. It is used in the manufacture of chlorides and chlorines. It is used to remove scales formed inside the boilers. The process is called descaling. So student, ये आपके hydrochloric acid के use है. Now we are going to discuss about the uses of sulfuric acid H2SO4. It is used in the laboratory as an important reagent. It is used in storage batteries. It is used in the textile, paper and dyeing industries. It is used in refining petroleum. It is used in the manufacture of fertilizers like ammonium sulfate and calcium superphosphate. Now we have classification of bases. Bases can be classified as a strong and weak bases. Following are the example of a strong and weak bases. Here we have strong bases: sodium hydroxide NaOH, potassium hydroxide KOH, etc. Now we have weak bases: magnesium hydroxide MgOH whole twice, ammonium hydroxide NH4OH, etc. Now we are going to read about the properties of bases. Here we have properties of bases. Bases have bitter taste and soapy touch. They turn red litmus paper into blue. Bases reacts with acid to form salt and water. Here we have uses of bases. Use of some of the important bases are as follows. Here we have calcium hydroxide is a strong base and commonly known as slackline. Its uses are: it is important constituent of many pesticides used in agriculture. It is used for neutralizing acidic soil. It is used as a substance for cement in low-cost construction. So students, these are the use of calcium hydroxide. Now, sodium hydroxide. Sodium hydroxide is also a strong base and is commonly known as caustic soda. Its important uses are as follows. It is used as a laboratory reagent. It is used in laboratory for the absorption of gases like CO2, SO2, etc. It is used in the refining of vegetable oils. Now we have potassium hydroxide. Potassium hydroxide is commonly known as caustic potash. Its important uses are as follows. It is used as absorbent for CO2. It is used in the manufacture of soft soap. It is used in the preparation of biodiesels. Now we have magnesium hydroxide. Magnesium hydroxide is also known as milk of magnesia. It is used as antacid. Now we have ammonium hydroxide. Ammonium hydroxide, its important uses are as follows. It is used in the manufacture of household cleaners and many other chemicals. It is used in the manufacture of ammonium nitrate fertilizer. Now we have alkalis. Water-soluble bases are called alkalis. Examples are sodium hydroxide, potassium hydroxide, etc. Now, neutralization. Neutralization is a reaction between an acid and a base, forming salt and water with the evolution of heat. When an acid solution and a base solution are mixed in suitable amounts, both the acidic nature of the acid and the basic nature of the base are destroyed. The resulting solution is neither acidic nor basic. Thus, the neutralization reaction has taken place. Acid plus base. After reaction, salt plus water, heat evolved. Examples are HCl hydrochloric acid plus NaOH sodium hydroxide. After reaction, NaCl sodium chloride plus H2O water. So student, जब हम एसिड और बेस की रिएक्शन कराते हैं उसको हम न्यूट्रलाइजेशन बोलते हैं. न्यूट्रलाइजेशन इन द सेंस कि एसिड और बेसिक दोनों ही नेचर आपके प्रोडक्ट में नहीं आती हैं, आपको कुछ नया प्रोडक्ट मिलता है, दैट इज सोल्ट. गेट इट स्टूडेंट? नाउ वी हैव एन एक्टिविटी. Activity 4. To be demonstrated by teacher in the class. So student, this activity demonstrated by your teacher in the class. Fill 1/4 of a test tube with dilute hydrochloric acid. Note down its color. Note down the color of the phenolphthalein solution. Also, add 2 to 3 drops of the indicator to the acid. Now shake the test tube gently. Do you observe any change in color of the acid? Add to the acidic solution a drop of sodium hydroxide solution by a dropper. Process of neutralization, acid plus indicator. Now students, we have neutralization in everyday life. Soil treatment. Excessive use of chemical fertilizers make the soil acidic. Plants do not grow well when the soil is either too acidic or too basic. When the soil is too acidic, it is treated with bases like quicklime, calcium oxide or slaked lime, calcium hydroxide. If the soil is basic, organic matter is added to it. Organic matter releases acids which neutralize the basic nature of the soil. So student, अगर हम बात करें soil treatment की, अगर आपकी soil over limit acidic होगी या over limit basic होगी तो plants grow नहीं करते. तो उस nature को neutralize करने के लिए अगर आपकी soil बहुत ज़्यादा acidic है तो हम बेसिस का यूज करते हैं, जैसे कैल्शियम ऑक्साइड, कैल्शियम हाइड्रोक्साइड का, या फिर अगर आपकी सोइल बहुत ज्यादा बेसिक है तो हम कुछ एसिड्स का यूज करते हैं ताकि आपकी सोइल को न्यूट्रलाइज किया जा सके. नाउ वी हैव ant bite treatment. When an ant bite, it injects the acidic liquid formic acid into the skin. The effect of the acid can be neutralized by rubbing moist baking soda, sodium hydrogen carbonate or calamine solution which contains zinc carbonate. So student, अगर आपको आंट जो है काटती है तो आपको क्या करना चाहिए, जो आपका सोडा होता है उसको रब कर लेना चाहिए, या फिर एक कैलेमाइन सॉल्यूशन होता है उसे आप रब करेंगे तो उसका इफेक्ट खत्म हो जाता है. नाउ वी हैव ट्रीटमेंट ऑफ इंडाइजेशन. हाइड्रोक्लोरिक एसिड इज प्रोड्यूस्ड इन द स्टमक टू डाइजेस्ट द फूड, but if too much acid is produced in the stomach, it causes indigestion. Indigestion can be treated by taking antacids like milk of magnesia, which contains magnesium hydroxide. It neutralizes the effect of excessive acid. Students, we have salts. Salt is compound formed by the partial or complete replacement of the hydrogen of an acid by a metal or an electropositive radical. सो स्टूडेंट सॉल्ट क्या है, कंपाउंड है, कब फॉर्म होता है, तो पार्शियली या कंप्लीटली जब एसिड से हाइड्रोजन रिमूव हो जाता है. Here we have some reactions. HCl plus NaOH after reaction NaCl plus H2. Then we have H2SO4 plus NaOH after reaction NaHSO4 plus H2O. This is partial replacement. Now come to the next. We have students H2SO4 plus 2NaOH after reaction Na2SO4 plus 2H2O. This is complete replacement. Then we have HNO3 plus NH4OH after reaction NH4NO3 plus H2O. Now, in the previous phase reactions, the hydrogen atom of the acid has been replaced by a positively charged atom or group of atoms NH4. Look carefully at the formulas of salt in the above reaction. So, students, now look at the formulas of salt. We have sodium hydrogen sulfate NaHSO4 is formed by partial replacement of hydrogen atom H of sulfuric acid H2SO4 by sodium atom. Then we have sodium sulfate Na2SO4 is formed by the complete replacement of both hydrogen atom of sulfuric acid by two atoms of sodium. Then we have sodium chloride NaCl is formed by replacing hydrogen atom from molecule of hydrochloric acid HCl by sodium atom. Then we have ammonium nitrate is formed by replacing the hydrogen atom of nitric acid HNO3 by an ammonium group. So student, that's how you can read about the reactions कि आपके HCl में H को रिमूव करता है, Na रिमूव कर देता है. अगर हम सोडियम हाइड्रोजन सल्फेट में देखें तो एक एटम को हाइड्रोजन के रिमूव करता है, सल्फर एटम. So that's how क्या होता है, replacement reactions होती है. Now we have properties of salts. Salts are mostly solids and high melting points and high boiling points. Salts are usually soluble in water. Solution of salts in water conducts electricity. Now students, we have a table. Name of salt, chemical formula, parent acid, uses. The first we have sodium chloride, common salt or table salt. Chemical formula NaCl. Parent acid hydrochloric acid HCl. Uses. Used as essential food material. Then we have sodium carbonate washing soda Na2CO3. Carbonic acid H2CO3 is parent acid in cleaning, water, softening. These are the uses of this salt. Now we have calcium carbonate, marble lime chalk. Chemical formula CaCO3. Parent acid carbonic acid. Uses as marble. Then we have copper sulfate blue vitriol. Chemical formula CuSO4. Parent acid sulfuric acid. Uses as fungicides. Ammonium sulfate chemical formula NH4 whole twice SO4 sulfuric acid parent acid. Uses fertilizers. Ammonium nitrate chemical formula NH4 2NO3 nitric acid parent acid fertilizers explosive. Its uses. Now we have calcium phosphate. Chemical formula CaPO4 whole twice phosphoric acid parent acid. Uses making fertilizers. Now students, we are going to read about acid rain. The rain containing excess of acids is called acid rain. The rain becomes acidic because carbon dioxide, sulfur dioxide and nitrogen dioxide, which are released into air as pollutants, dissolve in raindrops to form carbonic acid, sulfuric acid and nitric acid respectively. Acid rain can cause damage to buildings, historical monuments, plants and animals. So students, what we learn in this chapter, now we are going to discuss it in a nutshell. Acids are sour in taste, bases are bitter in taste and soapy to touch. Acid turns blue litmus red, bases turns litmus blue. Bases turns red litmus blue. Substances which are neither acidic nor basic are called neutral. Indicators are the substances which change the color of the solution of acidic or basic substances when added in the solution. Litmus is the most commonly used natural indicator. The solution which do not change the color of either red or blue litmus are known as natural solutions. Salts are formed by reaction between acids and bases. Here we have some keywords. Acid, the substance that has sour taste. Alkalis, water-soluble bases. Base, a type of chemical which feels soapy when touched. Basic, A dye which turns red in acid and blue in base. Indicator, chemical that change their colors in acidic or basic media. Neutralization, the reaction of an acid with a base to form a salt and water. Then we have salt, a substance formed when acids and bases react with each other. Thank you, students. We will meet again in the next chapter.